Welcome to Herbert Junior Surface Grinder Part 12, and in this video you'll see me repair and fit these bellows and the ones on the screw below, and also you'll see me improve the oil feed to the saddle lead screw and fit that. But first, a few words about fitting the nut in this shaft to respond to some of the comments actually. So a couple of weeks ago I fitted this new nut to this shaft here, and it's secured with a couple of screwed pegs, and there was much discussion why were the pegs inserted at an angle, drilled and tapped at an angle, this way, yeah? And we decided, I think, that they weren't deliberately drilled at an angle, it was more that they'd run off because this is steel and this is bronze. So people said it would be better if I'd used a stub drill or an end mill or a slot drill and drilled at 90 degrees rather than trying to do it at an angle like that. But how would I have held this to do that work? So I've got a couple of ideas, the ways I would have held it if that's what I was going to do again. So one on the shaper and one on the milling machine. If I was doing this again on the shaper, I would put the shaft in there in that vertical V. I'd probably have to drill a couple of holes in here, put some clamps in to hold this in this position, and then I would fit this vertical milling head that I made quite some time ago onto here, get the table across, and then using this screw, the top screw here, I would use my slot drill and make the holes vertically, which I would then tap and put the pins in either side of that bronze nut. Quite a neat way to do it, I think. And the alternative would be to put this shaft into a couple of V-blocks on the milling bed, take the vertical head off, put either this chuck or a collet chuck into the horizontal spindle, line this up, move the table in, and then machine in with a slot drill, much the same way. And if I got these two horizontal, then all I would need to do is do one, move the table across and do the other. So a couple of fairly easy ways to do it, but I just got hung up on the idea that these had to be drilled at an angle, that was all. Okay, surface grinder. Fitting these gaiters is proving to be very difficult. They're not damaged as such, they're just old and quite floppy, and trying to get this bit of the gaiter over this block and then this metal clamp in place and the screws in, it's really quite a job. I think it's going to take me a while. How about this? Only today my son bought these little clamps. We went to the Auto Jumble this morning and he said, well, these look quite useful because I've got some bigger ones, and I said, yeah, they'll be great for something. And what are we, about 2 hours later? Hey son, have you got those clamps that you bought this morning? I can't see what I'm doing now. This is the last screw in this one. If I can just get it in. Nope, cross-threading. Well, after a struggle it's on. The trick seems to be to get this front screw in first and then work your way round. Top gaiter. It's basically in good shape, but it's damaged here, so I'm going to take a couple of bellows off it. I don't think it'll matter, and this top bracket is all out of shape, so that needs straightening up. So this is riveted to the bellows, so I've got to get those rivets out first of all. Let's put the glove on just in case. I know somebody's going to say you shouldn't wear gloves on rotating machines, but then again, this could rip out of here and spin round. It's only soft. That's out. So I think I'll cut it there, I think. Take those two top bellows off and then remake it on this one. Done. I think that'll do. Now there's one fault on it. If I can find it, it's there. There's just a little bit of a split there. I don't think that matters. I think that'll be okay. I thought this would be a quick job, but I should have known better, because doing this top bellow and the bottom one has been the best part of an afternoon again. Really fiddly. But I think you can see probably that this table's about as low as it gets, and there's plenty left on these bellows, so taking those two layers off hasn't made any difference. Good. And it works, my goodness. Next, saddle screw, sort that out. You may have seen the video where I made this tap to make a new nut for this saddle lead screw. Now that's the old nut. But now it's time to turn our attention to the lead screw itself before we fit it. Now the lead screw goes in that hole there, and it's clamped by that big, large Allen grub screw. And that screw impinges on this part of the lead screw, with this hole underside, which lines up with an oil pipe that comes up, well, actually from the oil pump within the knee, and the oil goes into that hole there, and this screw is hollow all along. And the idea is that as you operate the pump, the oil flows down there right through the center of this screw, comes out, oils this nut, and it also oils the handle at this end and its bearing. And it doesn't work very well. A couple of reasons for that. First is that the fitting which feeds into this was loose anyway, and the oil flow is very limited because there are metering valves in each of the oil feed lines. So with the nut loose, sorry, the fitting loose I meant to say, and this is absolutely ruined. Can you see the surface on that? It's all beaten up like crazy. With such a low flow of oil, there was no chance of anything getting down here, and I think that's why that nut completely was worn out. So I'm going to clean up this part of the screw, just take a little bit off it, and I'm going to look at putting a couple of O-rings, one either side of this. And then also, just out of interest, you can see at times this has been clamped in place without this down. If I can find it, look, there's a clamping point there. You can see a circle made by the bottom of that. But there's other places on it, I can't see it readily, but there's other places on it which tell me that it was not clamped with that downwards. Can't find them right now, but they are there. Oh, it's just ruined, look at it. I mean, that looks like it's been in a vice or something here. Oh, there it is. Look, that's the mark. Hopeless. I don't know why they took this out so many times. So that's where it should be clamped, with the oil hole downwards to line up with the fitting. But you can see also, look, it's been clamped there as well. You see the marks? hopeless. This is a difficult shot to get, but there's the hole at the back that the lead screw goes into, and there's the fitting. And that's right back against the vertical face of the column. And you can see I've put a couple of washers there on that fitting because it was just wobbling completely loose. Let's try and get some measurements to figure out where the O-rings should go and where that screw lines up. So you can see the shape of the knee here. That's the boss, that's the screw, that's the front. Try with this. So I'm measuring up to the boss now, and it's 215. That dimension, 215 to the start of the boss. So having got that measurement, where's the screw? Oh, that's only 220. So that edge is only just further on, 5mm on from that edge. So that screw is 1/2 inch. Now I normally measure in inches or millimeters, but all the females in my family seem to measure in centimeters. It's most confusing. And I've just measured from there to the edge of that oil fitting, and for the thousands of metric women who might be watching, I've called it 22.2 centimeters. So what that tells us is that hole was drilled right through from there. Okay, now the next I want to measure to the back of this. Now the back of the column is about there somewhere, and there's a bit of a gap, but it's not much. I think we can figure this out. Make a guess at it anyway. So I've measured from here to that back plane, 255mm. I think we'll forget centimetres. They're just too darn confusing. And then I'm just showing a piece of video I took earlier in this series, and you can see that boss is just set down from that plane, which goes against the column. So I'd probably give that 4mm, something like that, 5 maybe. So just to complete the measurements then, I can't measure the screw from this end because I have no reference. It's got to be against that point there, and that dimension from the back of the boss assumed to this line where the holes were drilled, 24.5mm. So I'll mark that out now on the screw and see if anything lines up like the oil hole. 5/100ths of a mil, 2 thou, not worth worrying about. This part here, this unadulterated part, goes into the boss in the knee, as it should. But as soon as it comes to these parts, which are all kind of, you know, puckered up and welled up, this sticks and you've got to hammer it in. Well, that's no good at all. So I'm just going to skim it and make it all to this, at least take these big rough wheels off it. Right, 24.5mm will be about not far off the middle of that slot actually, about there. Yes, that's 24.5. So that'll be where the oiler pipe comes in, about there, if this goes right to the back of the boss. About there. So you can see why they've got this slotted. And if we say that the boss is 36 long, and this lines up with the back of the boss, that puts us about there. So if I'm putting an O-ring on, 2 O-rings actually, there and there would be okay. I tell you what, these gloves are okay, look, no splits in those. My wife saw a comment from a subscriber who said, look, try these. And she bought them for my birthday. And so far, so good. I suppose now I've got to say what they are. Skytech. They weren't excessively expensive. About the same as those black fish scale ones I had In fact, they may even be cheaper. I'm cutting 2 grooves, 2mm wide, 1.2mm deep. I'm taking the risk of doing this on camera. One millimeter, 1.1, 1.2. Looks all right. I want to put a registration where that screw would go, which would be land about there. So that mark there and there is about where it should be. There's actually a sort of stripe in the middle. So I'll see how wide that is, because that Allen grub screw has a dog point on it. Well, sort of a tapered end on it. So I'll put a flat spot on there, directly opposite this. And I guess those of you with a keen eye will see that these are not symmetrically cut. Well, that's because the end would be about here. This is where it would come out of the bus, where my fingernail is, and I'm going to shunt it a bit this way. So there's loads of spare at this side. There's not so much spare here, so I needed to take that ring quite close to that opening. And then instead of finishing about there, it'll finish more like there. It might seem like a lot of work to measure all that up, just to put in 2 grooves and 1 flat. But I've learned from experience, trust nothing, assume nothing. And then you'll probably get it right. Can you see I've also put a little pop mark on there? So when I look into the knee, that should be at the top, because it lines up, if I can find it, there we are, with where that flat's going to go, which is there. And that'll just be another confidence check. I should feel this locate an index on this when I screw that screw in, but to be super sure, I've got that pip as well, which ain't going to focus now, is it? I kept getting a belt slapping noise, and I'm thinking, what on earth is it? Look at these belts having a fit. But watch this. Gone. That's all it was. Resonance of some kind. That's sufficient, I think. Let's just try it on. No, can't get it over. I need to work out how to hold down this big vise. Yeah, that'll do. Before I fit this, there's one more thing I want to think about. So we've got the 2 O-rings here. We can be sure that the oil is going to come into that slot and come down the center here. And then, you know, by that, the oil is going to come out of here and lubricate this area, this bush, this bearing here. But I'm not sure how does the oil get to this screw here. I can't really see it. I don't understand. So I'm going to drill a hole through this to give lubrication, maybe halfway along. In terms of position, well, there's the hole, the feed hole. That's at the bottom. So I don't want to drill a hole at the bottom, because the oil might run out of the hole there before it gets to here. I don't want it at the top, because it may come out of here before any comes out onto the screw. So I'm going to drill it sort of 90. So if this is the correct orientation, I'm going to drill into the side here, is what I'm saying. about halfway along, and I'll make the hole the same size as that hole. For no other reason than it'll be the same. So much for theory. In the real world, I had to fit the drill into the thread root, so that's a 2mm drill. To fit this, I need to put a lead onto the front of the boss that this is going to push into, otherwise it'll just slice these O-rings. So I've made up a kind of rig, and the rig looks like this. So this is something that Jason sent me. It's actually an extension handle, and these were supposed to go on the end there. There's a keyway in there, but I've tapped it 5mm metric course and put this countersink in the end. And I should be able to put that in there and put a lead on it, countersink it in other words. If I can find the location, there it is. Now I'm just going to put a bit of grease on first, and I'm going to try and not drop that inside. The idea of the grease is to catch the swarf. Let's see if I can find this again. Feels right to me. Looks like nothing this, doesn't it? But it's the culmination of a lot of work.